Did you know that everything from medicines to the plastic we use is based on the organic chemistry? Welcome to Chemistry Portal. I am Sudhanshu Kumar, and in this series we will cover organic chemistry from the absolute basics. Whether you are preparing for IIT JEE, NEET or board exam or any types of exam, this course will help you master the organic chemistry step by step. In today's lecture, we will understand what organic chemistry is and why carbon is unique and why and and its importance in our daily lives. And by the end of this video, you will have a strong foundation for the advanced topics in the organic chemistry. If you find this helpful, make sure to like, subscribe and share. Let's start. So first of all, have you ever wondered what makes organic chemistry organic? No. Actually, what happened? For the century, in the early century, like in the back in the 18th century, scientists believed that organic compound had a mysterious vital force. Vital force means it's like some soul in the molecule, some god, a spirit, some mysterious force is present in the organic molecule, and that is supposed to be believed in the early 18th century. Okay, but what if I told you that this idea was completely shattered by a simple lab experiment? So let's start the fascinating history of organic chemistry and how it all started with a mistake. So first point is what? Early belief. What the people think about this organic chemistry in the early 18th century. So first topic is our early belief. Early belief, and that is the myth of vital force. The myth of vital force. Vital force. So, if you go in the back in the 18th century, chemists thought that compounds from the living organism were special and could not be created artificially in the lab. Okay, so we can write here in the early 18th century, in 18th century, compounds from living organism were special. Okay, compounds from living organisms were special and cannot be created artificially. Okay, but so in the 18th century, compounds from the living organism were supposed to be special and cannot be created artificially. Okay, so in the 1807, one scientist, Swedish scientist, John Jacob Berzelius, he classified the compound into two types. Okay, so let's write here. In 1807, one scientist, Swedish scientist, named John Jacob Berzelius. Okay, Berzelius. And this scientist, this Swedish scientist, he classified the compounds into two types. and that two types of compound is what? So he classified the compound into two types. First compound is first classification is organic, and the second one is inorganic. This is your inorganic, and here organic. So John Jacob Berzelius, he classified the compound into two types. First is organic and second one is inorganic. So let's talk about one by one. And in the organic compound, he told organic compound is such a compound found in the living being, found in living beings. Okay, found in the living beings. Okay, and such compounds contains a special vital force, a special vital force. Vital force means what? Vital force means it's like a mysterious force. Mysterious force. Okay, like a soul, a spirit. Okay, and the inorganic compound, such compounds which found in the minerals, found in minerals. Okay, and in this compound, no such vital force, okay, means no such mysterious force in the inorganic compound. And this is the classification of compound done by scientist John Jacob Berzelius. One is organic and the second one is inorganic. Organic compound is such compound which is found in the living beings, and that compound contains a special mysterious force, a special vital force. But in the case of inorganic compound, such compounds which is found in the minerals, and there is no such vital force in such inorganic compound. But at that time, chemists thought it was impossible to create organic compound in the lab, right or not? But then came a groundbreaking discovery that changed everything. Now the big twist will come. Now the big twist came, accidental discovery done by the Wöhler. So now, right here, and it is impossible to create organic compound in the lab. And this thing said by the earlier scientists in the 18th century, we cannot make organic compound in the lab. But wait, then the big twist came. The German chemist Wöhler, in 1828, he discovered a reaction in which he prepared an organic compound from inorganic compound in the lab. So now let's talk about it. Now the big twist came. So the second point is what? Second point, the big twist. And that big twist is Wöhler accidental discovery. So in 1828, German chemist Friedrich Wöhler So he was a German chemist, and he was the he was doing some experiment with ammonium cyanide that is a completely inorganic compound, and but when he heated it up, when he heated that ammonium cyanide, something unexpected happened. Instead of ammonium cyanide, he got urea. Yes, the same urea that is found in the urine. And urine came from the living being. So all the contradiction removed. Why? Because Wöhler, he was the first chemist who synthesized organic compound in the lab. Understood? Okay, so we'll write here inorganic compound to organic compound in the lab. Organic compound in lab. He was the first scientist. Okay, Friedrich Wöhler. So, and that inorganic compound, it was ammonium cyanate, NH4OCN. This is called ammonium cyanate. Ammonium cyanate. And he was doing some experiment, okay, and accidentally he discovered he made it organic compound in the lab. So when he hit this compound, he got urea, C double bond O, NH2, NH2, and this compound is called urea. Okay, and this urea is found in the urine. This urea compound, this molecule, is found in the urine. So we'll write here found in urine. Okay, understood? I hope there is no doubt here, right? Okay, so first of all, very basics. In the 18th century, scientists thought that compounds from the living organism were very special and cannot be created artificially in the lab. But, and in the 1807, a Swedish scientist, John Jacob Berzelius, he told that he classified the compound into two types, organic, inorganic. Then, organic compounds are such compound which is found in the living being and that contains a special vital force that is a mysterious force. And in the case of inorganic compound, such compound which is found in the minerals, okay, and no such vital force. But the big twist came when the Wöhler discovered the technique. He discovered the molecule, organic molecule, he discovered the organic molecule, organic compound from inorganic compound in the lab. Understood? Okay. So that's why, and this completely shocked the scientific world. Every scientist got mad. Oh my God, what he did, how he did, because they said that in the early 18th century, we cannot make organic compound in the lab. But now, after Wöhler discovery, every scientist is mad. How this is possible? So, it means if an organic compound could be made from inorganic material, then what happened to the vital force? Understood? Then what is the meaning of vital force? Right or not? And from that moment, organic chemistry definition was changed. Okay? From that moment, when the Wöhler did this discovery, from that time, scientists need to redefine the definition of organic chemistry. Now we will learn what is the modern definition of organic chemistry. So point number 3. The modern definition of organic chemistry. And after Wöhler experiment, chemists realize that organic chemistry is not about life, it's about carbon. Okay? It's about carbon. And now from that moment, organic chemistry definition was redefined. Okay? And now the new definition of organic chemistry is what? We can write here organic compound, such compound or any compound that contains carbon. Simple. Okay? Carbon. C. But wait. Not all the carbon containing compounds are organic. Understood? Not all carbon containing compounds are organic. Understood? Here are some exceptions that are still inorganic. Okay? So we'll write here some exceptions also. Some exceptions. Because general definition was given what? Any compound that contains a carbon is called organic compound. But we have some compound in which carbon is present, but that compound is not organic. Understood? That's why we have to make some, we have to note down some exceptions. Okay? So we have some exceptions here, and that is, we will write it here. Not all organic, not all carbon containing compound are organic. Like example if I give here, example like diamond, graphite has carbon, diamond has carbon, but still they are not organic. Okay? CO2 molecule having a carbon here, right? It should be organic compound, but no. CO2 is inorganic compound. It shows inorganic compound properties. Okay? Understood? And we have some more example. NH4, OCN, ammonium cyanate, Na2CO3, sodium carbonate. All these molecules having a carbon, but these are not considered organic. Okay? We have one more example, KCN. Okay? Understood? So these all are molecules are what? Inorganic. Okay? Inorganic. Clear? Right? Okay. But generally most of the carbon compounds are organic. Okay? Very few compounds having a carbon but belongs to inorganic. Understood? But most of the carbon compounds are organic. Okay? So write this also. Very important. Most of the compounds are organic. Very few belongs to inorganic. Okay. Now we will talk about why we are studying organic chemistry. Why organic chemistry is important. Right or not? We we have, if you see in your surrounding, the medicines, the chemistry of food, digestion in our stomach, like how the fuels like petrol and diesels are made, the structure of DNA and proteins, all are organic chemistry. Okay, organic chemistry plays a huge role in our daily lives. It helps us to understand how the medicines are manufactured, how the medicine work in our body, the chemistry of foods and digestion in our body, how the fuels like petrol and diesel are made, like all the structures of DNA, protein, vitamins, all are organic chemistry. Okay, so like agriculture, pesticide, insecticide, all things, or even the cloth we are wearing now, that is also organic chemistry. Organic chemistry is everywhere. Everywhere means everywhere. Okay, from laptop to iPad to a smartphone to paper to clothes to food, everything. Concrete, buildings, everything you will find you are surrounded with organic chemistry. Okay, so I will give you some real life example of organic chemistry, like uh, some molecules, some compounds. I will show here. Okay, so let me just okay. So if you see this compound, see here, I have some compound here. You can see here. So so this is your um, this is octopus. Okay, this is your octopus, and this octopus has some different kind of octopus. This is a ring, a blue ring octopus. You can see here there is a blue color a spot here. Okay, blue ring a spot here on this octopus, and this octopus is called a blue ring octopus. Okay, and this blue ring octopus, in this blue ring octopus, there is a venom. Venom means poison. Okay, venom, and that venom, that is called tetrodotoxin. Understood? In this blue ring octopus, the venom is found, that is called tetrodotoxin. Tetrodotoxin. Understood? And this is the molecule, this is the organic compound is found in this blue ring venom, and this venom can cause paralysis, even the uh, death also. Understood? So we'll write it here. This venom, this is the tetrodotoxin. Tetrodotoxin is a venom of blue ring octopus, and it causes paralysis, or even death also, due to this venom found in this blue ring octopus. Okay, understood? So these are, I told you now, organic chemistry is everywhere. Everywhere means everywhere. Okay, in the plants, in the animals, in the anything. So water bottle, plastic, mobile, laptop, cream, sun cream, anywhere, face cream, anywhere, medicines, charger, water, anything. Okay, organic chemistry is everywhere. Understood? Okay. Now this you can see this is a rose hip. Okay, rose hip is like a rose flower. Understood? No? This is the seed of rose. In this part, we have some seed of rose, and this seed of rose contains some vitamin C. And the vitamin C formula is what? This is the compound called vitamin C. Understood? And this compound is found in the rose hips. And we know that due to deficiency of vitamin C, we got a scurvy disease. Okay, a scurvy. Due to deficiency of vitamin C, we got disease that is called a scurvy. Understood? And we know that to prevent the scurvy disease, we should take vitamin C in more amount. Understood? So this we can write here this molecule. This molecule is vitamin C is found in the rose hip. Rose hips contain vitamin C. Vitamin C and which prevent a scurvy disease. Okay, understood? Now the third part. This compound is called carmine. Carmine. Okay, carmine is a red color compound. Okay, red dye carmine, and this is produced by one insect that is called cochineal. Okay, cochineal insect, and that insect found on the cactus plant. Okay, cactus plant. So we'll write here. This is the carmine is a red dye carmine. It is organic compound. Carmine produced by cochineal insect. Cochineal is the name of insect. Okay, insect on the cactus plant. On cactus plant. Okay, on the cactus plant, this insect uh, found. Okay, on the cactus plant, this insect cochineal will produce carmine. Okay, red dye carmine compound is produced. Okay, understood? And now the last one, this is your morphine. And morphine is you know that it is a pain relief medicine. In the medicine we also use. Okay, understood? And the morphine, this compound, it came from the opium poppy. This is called opium poppy. These are the poppy. Okay, and from the opium poppy we got morphine compound, and that is a very addictive, used in the drugs also. Okay, understood? So we'll write it here. So this is your morphine, right? And morphine came from opium poppy. You know, in the Afghanistan, there is so much cultivation of opium poppy, so much. Okay, understood? So opium poppy contain morphine, and that is addictive. If you take one time, you want to take two times, like this. Okay, addictive, pain relief. Understood? Okay. So these are all about organic compound. And one thing you will observe here, कि all the organic compound having a carbon, all the carbon, we have carbon. Okay, understood? So so why the carbon is so special, and how it forms millions of compound, understood? We will see in the next video, like why carbon is so special and how it forms millions of compounds in the organic chemistry. Okay, so I hope you find this story mind blowing, like Virgilius classification, and then the Wöhler came, and so much a story going on. Okay, I hope you find this story mind-blowing, and let me know in the comments and hit the subscribe button for more exciting chemistry lessons, and don't forget to like and share this video. In the next lecture, we will explore why carbon is so special and how it forms millions of compounds. Thank you. Stay tuned. Thank you everyone. Thanks again.